All right, lesson 1.5 is what we're going to take a look at today. And I want to begin actually showing y'all some PowerSchool. I updated the website. I'm trying to make things more clear. What do I mean by that? So if you go to your PowerSchool learning page, so the home page that I've told you to bookmark here looks like this. And on the Zoom link, I want to draw your attention to is if this link is not working for you on a Chromebook, which I know a lot of students have had trouble with that. If you go down to the fourth bullet, it says, if you have an error signing in, please follow all these steps in this video. If you click that link right there, and really quickly, I'll walk you through how to fix the problem. It's a very simple fix, but basically what it takes is you go to zoom.us, zoom.us. That's just their home site for Zoom. And if you sign in right here, this button next to the orange that says sign in, you click that and use your sign in with Google. You'll scroll down on your Chromebook, the screen cuts off about right there where my mouse is. But if you go down to sign in with Google, you choose your Dallas ISD account. And then the way it'll always work for you is after you sign in there, this will not show up on yours because you don't have recurring meetings that you've scheduled, but I do. But what you'll do click is join a meeting. When you click that join a meeting, it's going to ask for your meeting ID. What you do is you go back to the PowerSchool Learning. That ID number, I have it listed right there, and your password is on the link right below it, on the bullet right below it. If you type those in from there, you will be able to get into my class. That's just a way of making sure your name is put in right. So it's another way for attendance and just for integrity of what's happening and for safety. So Zoom, if you haven't paid attention to the news, a lot of people have hacked into Zoom and stolen people's data. I'm just trying to keep you safer, and so that's one way of doing so. That's the home page. What I want to show you though is what I've edited over the weekend is if you go into chapter 1, I'm trying to make instructions more clear for what's happening each day. So before I was listing this and I had some things saying optional, whatever, but starting in 1.5, I made it a lot clearer. So if you go to 1.5, you'll see what the lesson is, what we're learning, what you're expected to know by the end of the lesson. And then I numbered it. Number 1, take your attendance. Number 2, watch these YouTubes. With number 2, you have some option things. And then here are your assignments for how you'll get your grade on these 2 links. So I did this. I'm going to start giving you this look each time, just trying to make it clear. It's almost like an agenda. What are we responsible for today? There they are. Okay, with that, let's go look at our lesson. So I've given a couple different bell ringers here. Number 1 and number 2 deal with continuity. I want you to know what is the continuity of these 2 functions. Now remember that there are 3 types of discontinuities. If something's continuous, that means there's no breaks. So something could be continuous. That's an option. But there's 2 or 3 other options. You could have an infinite discontinuity, and that's where the graph breaks and goes to infinity at the break. You could have a removable discontinuity, and that's where you just remove one little dot and it's like an open circle. It looks continuous at first, so it passes what I would call the eyeball exam, but when you investigate it closer, you see that there's actually a little open circle. Or you could also have a jump discontinuity, and that's just where there's just a segment missing from the graph. Jump discontinuity. And so if we graph these, we'd be able to determine the answers. And I'm trying to remember if I have it saved on the next page, these graphs. I do. So here's the first one. Here's the second. I named the first one F1. This one's G. So on this next picture, you're going to see this as F and G right here. Okay. So when you look at number 1 actually has multiple breaks. So how do I know there's multiple breaks? Let me just ask you guys. How many different pieces of graph do you see that are up here in blue? How many different pieces of graph for you? I have 3 pieces of graph. So we have this first piece on the left. There's piece number 1, piece number 2, and piece number 3. Now here's the deal. If you have 3 pieces of graph, that means there has to be 2 breaks. There's a break between piece 1 and piece 2, and there's a break between piece 2 and piece 3. So there's 2 breaks here. And so specifically, the way these breaks work, you look at the x values at which they break. And so this piece is breaking and going to infinity here and here. And it looks like it's breaking on this x value. So what x value is that? If it's left 2 units, would that be a -2 or a +2?
-2.
-2. So at x equals -2, we have a break. So it's not continuous, it's a discontinuity. The graph is going to infinity at the break. This one's going down to infinity, this one's going up to infinity. So if I use my previous slide, which of the 3 types of discontinuities do you think it is? Do you think it's I'm sorry, I wrote this one wrong. I wrote infinity discontinuity. I shouldn't have wrote that. I should have wrote infinite. Let me see if I can correct that. Infinite discontinuity. Which that's what this one is, because the graph's going to infinity. That one has an infinite discontinuity. So at x equals -2, we have an infinite discontinuity. Okay, I'll say it one more time. We looked at the graph, we saw 3 pieces. 3 pieces means there must be 2 different breaks. This graph broke from between here and here and right there at this spot. So we have 2 different breaks. At this x value, where these 2 pieces break apart, the graphs are going to infinity. So we would call that a infinite discontinuity. Okay, at what x value does the second break occur? So our second break occurs at x equals 1. Here at x equals 1, we have our next break. So at x equals 1, what type of break is it? If the graph, this is not an open circle, it's just a jump. It's like a segment of line is missing. So that's what we call a jump. X equals 1 is a jump discontinuity because the graph jumps from one place to another. Now, I'm going to differentiate here. This one was infinite. You don't say the graph jumped from infinity to infinity or negative infinity to positive infinity. We don't say that. We just call that an infinite break. But this one is a jump because it jumps from being on the x-axis to up above. The graph, it's like you just picked up your pencil, moved it somewhere else, started drawing. That's a jump discontinuity. So that's the differences between infinite and jump. Now this graph, how many pieces of graph do you see? How many pieces of graph do we see? So when we look at this picture, when I graph the second one, it looks like there's 2 pieces of graph. It looks like it's 1 and 2. So if there's 2 pieces of graph, that means there must be a break. And so I'm seeing this break. Let me change color so it doesn't blend in with my 1 and 2 here. I'm seeing a break at, let's count out what value that is. -1, -2, -3, -4, 5, 6, 7, 8. It looks like it's going to be at x equals 8 that this graph breaks apart. At x equals -8, I'm sorry, x equals -8. That's where that graph seems to break apart. That's such an ugly x equals -8. That's where the graph breaks apart. Okay, so at x equals -8, what is the graph doing? Is it only missing? Is it like one little dot is removed? Does it jump? Or does the graph go to infinities at that break? What's the graph doing at that break? This one looks like it's going down forever. This one looks like it's going up forever. So since the graphs are going to infinity, this is a infinite discontinuity. Very good, y'all in the chat. Very good. You are correct. This would be an infinite discontinuity. But this problem has another break, and it's a hidden break. And so I'm going to show you from Desmos how you can do this using technology. Here's what you would look for, just as this is a hint that you'll learn in chapter 2, is if you have a denominator and the power is 2, see how this x has a power of 2? That means there can be 2 breaks. And so using Desmos, I'm going to show you how to graph this. So I'm going to use this graph in Desmos. What I'm going to do is I'll go to desmos.com and then /calculator, but you can just go to desmos.com and then click calculator, and I'll type it in g of x equals, and I remember it was a fraction, so that's the slash symbol, Now let me go back and see what the problem is. Just do it like this. So you are able to see both screens right now, right? You're able to see on the left my smart board, and on the right Desmos. Is this correct? Is this correct?
Yes, sir.
Yeah. Okay. So now I'll be able to type in my equation easier. X minus 3 on the top, x squared plus 5x. To get us power, by the way, in Desmos, you hit Shift 6. That it's called caret. It looks like an up arrow. Minus 24, and then plus 3. So here's my graph, and it looks like, I'm going to minimize this part. It looks like they only have that one break at -8, the infinite break, but it actually has a second. Here's how I know. If I just touch my graph with my pencil and see as I'm moving it, I have a solid dot moving along the graph. Do you see how that's working? If I go, I'm going to give you a hint, it's going to be at +3. But if I move this around really slowly, somewhere it's going to open up and be an open circle. And so you might not know right away, so you'd have to just look at every single x value. So you'd be looking at like x equals 1 and so on, but it's going to be at 3. So I'm going to wait, here's 3 right there. So when I get to 3, you see how it went open? Whoops, where'd it go? It went, yeah, it's so hard to hit that spot. You see how it went open right there at 3? Are you able to see that right now on your screen, or is it too small?
Yeah,
you can tell that that dot is open. That's a break. Now I want you to look on the left side of the screen. There are 3 types of break. There's infinite, removable, or jump. We know it's not infinite because it doesn't look like the break on the left side of the graph. You've seen a jump. This graph's not jumping from one place to another. What's the only one left?
Continuous and renewable.
No, continuous means no break at all.
Oh, my bad.
So which one's the open circle? What's the only other discontinuity left over? Removable. It's a removable break. So this one is what a removable would look like. Whoops. I tried to take a picture right there. Let me try this again. There we go. That's what it would look like. Now, there's something else you can do in Desmos to help you out, and that is use a table. Now, I'm giving you a lot of instructions right now. We're going to go over this in chapter 2. But if you use a table, so if I hit this, you can copy the equation and then hit the table, convert to table, and then it'll show you your values, which I don't know. You define g of x more than one place. Oh, whoops. Maybe I wasn't supposed to copy it. I was just supposed to hit table. And so it'll show you the x values. And so if you're like, hey, I'm not sure if it's a break somewhere, you can just type in the x value. So you can just keep typing them in until you find it. So -8 we saw. But when I look at this graph, I don't see another break. And it's like, I think there should be 2. Mr. Voorhees said if you have the power of 2 in the denominator, you should have 2 breaks. So I have the one at -8. Where's the other break? You just start typing in the numbers. So I got -2, -1, 0, 1, 2. If I type in a 3, look what it says, undefined. So that's how you can find your breaks. You can just start typing in numbers. I'm just typing in the keys. And if they give you real number answers, then those are real values. That means the graph exists there. It's not a break. It's not a break. It's continuous at all these places. However, the graph is broken when it says undefined. So those are 2 breaks. It's at -8 and 3. So again, how I got that is if you hit the edit and then you hit that convert to table, that's how I got, whoops, I did not mean to do that. That's how I got this table up and was able to find it that way. So there's 2 ways of finding your answers, but we just kind of found them right there. So this one, if I were going to draw this perfectly, I would need to go to the x equals +3 and draw an open circle. There would be an open circle on that graph. Let me get the color right. Since it's a red line graph, I'll do an open circle there at x equals 3. Now, you might be thinking, how would I know this by algebra that is a removable discontinuity? Or you might be thinking, why did they even call it removable? I get why you have what's called infinite discontinuity because the graph goes to infinity, but why do you call it removable? Here's why. If you do what we learned the very first lesson of the school year, the X method, where you take your A times C and your B factor down here, which in this problem, here A is 1 because there's no number there. So A is 1, B is 5, and C is -24. Right now I'm showing you the algebra. 1 times -24 is -24. B is 5. So you'd ask yourself, what are factors of negative 24 that add up to be 5. So if I did my chart, I'll list them out. The options are 1 and 24, 2 and 12, 3 and 8. And as soon as I see this is at 8, I know 8's got to be the number, but I'll keep going. And there's also 4 and 6. Those are the numbers that can multiply to give you 24. The only ones that could somehow combine and give you 5 are 3 and 8. These could give you 5 if it was 8 minus 3. So our numbers were 8 minus 3. So then you'd split your power, and so what would happen is you'd be left with g of x equals, we had x minus 3 in the top, but in the bottom I'll rewrite it as x plus 8 and x minus 3. And then there's a plus 3 on the outside. Okay, so the reason why it's removable is because with the algebra, you see how in the top I have a factor of x minus 3, and in the bottom I have a factor of x minus 3? Whenever you have matching, you can remove these or cancel these from the problem. You could remove them. That's why they call it a removable, because you could remove them from the equation. They got canceled out. So if you're wondering why they call it removable, that's why. That's what happened there. This one never went away, so this was the infinite. And if you're like, well, that says positive 8, this says negative 8. Well, that's because we haven't set it to 0. You just say x plus 8 equals 0. And so x equals negative 8. That's why we got this one. And over here, the canceled part, the removed part, x minus 3 equals 0. Add 3, x equals 3. That's how those two answers show up algebraically. So I've shown you graph, I've shown you table, and now I showed you algebra, how you get breaks. And if you're wondering, well, how would I get jump algebraically? Jump happens whenever you have piecewise. Whenever these pieces, when you put in the ones into the equations, they don't equal the same number. So this graph, if you've typed in 1, we'll zoom in on it a little bit. Let me see if I can go closer. If you put a 1 into the top here, looks like it'd be 2 times 1 squared, which is 2 minus 2. You get 0. So this first piece hits at 0, because when you plug in 1, you get a value of 0. When you plug in the 1 there, you get 0. When you plug in a 1 here, 2 minus 1 squared, you get 1. So this value is, this one, when you plugged in 1, you got 0. This one, when you plugged in 1, you got 1. Since they're different values, it jumps from 0 to 1, you call it a jump. That's the algebra. But again, all that is in chapter 2. It's actually lesson 2-5, I believe. So that's going to be to come, but I just kind of previewed you on algebra. So that was the bell ringer. Today you're going to learn something else about functions and transformations. Many students love this lesson because it's a review of algebra 2. What you're going to talk about is that these different types of graphs, a line, a parabola, this line, or that's just a constant line. This one is a line with slope, cubic functions, square root, reciprocals or rationals, absolute values. All these graphs, what we're going to do is we're just going to shift them as we go along. So I have some rules that are you'll go over in the videos, but you're going to just see graphs that get shifted. So this blue one got shifted to the right and down to make this graph. And we'll talk about why was it to the right and why was it down, going off the numbers. So you'll just have a lesson where you go through and you do all this. So that's today's lesson. That's in the videos as you go through, which is a reminder, if you're in your Power School Learning, you go to lesson 1.5. That's where you'll get those right there. Now I'm going to hang around so I can answer any questions you might have on previous homeworks or anything like that. But that's what you're what's on task for today. So if you don't have any questions, you can go ahead and get started on lesson 1.5 by watching these videos. You can, if you've already taken your attendance, move on to here.